So, hello everyone, this is the Riot Science Club. I am Olivia Kowalczyk and I will be your host today. Warm welcome to all of you there. Welcome to all of our regular listeners and to all of those who are here with us for the first time today. It's lovely to have you all there. The Riot Science Club is a seminar series about all things to do with open and reproducible science. If you would like to learn more about us, there are some social links that you can follow in the announcements box. Just a little bit of housekeeping before we get started. So the platform we are using today is a one-way streaming service, and that means you can pause the video, you can rewind it, and you can also use the auto subtitling function. And all of those you can find in the sort of bottom bar of your Teams window. To ask your questions, you can use the Q&A box, and please make sure that you upvote the questions that you find interesting so that we know which ones to prioritize. Okay, so on to our main event today. So we are very excited to welcome our returning speaker, Professor Russ Poldrack. Russ is a professor of psychology at Stanford University, associate director for Stanford Data Science, and director of the Center for Open and Reproducible Science. His research work focuses on using brain imaging methods to study how the brain gives rise to the mind. And something that I think is even more topical for us here today in this space is that Russ is very passionate about improving the state of science and building tools and knowledge base to make research more transparent and reproducible. So today we have Russ with us to tell us a bit more about how we can use artificial intelligence in our research work. And I think that's a topic that just is really going to resonate with all of us here. So without further ado, take it away, Russ.
All right, thanks very much. Thanks for the invitation. It's nice to have a chance to give this talk. So I'm going to talk about something that I think is a lot of people are interested in right now is like how we can think about the role of AI assisted coding, and particularly in the context of making science better, which I know is a topic that many people here are interested in. So it's probably not I think you all know that we're at an inflection point around AI in general, and particularly around AI assisted coding. And here's just one example. This is a quote from Alan Downey, who's written a number of programming and statistics books. He said, this was last month, today I asked ChatGPT to solve almost every exercise in Think Python and in his data structures book, and it did. His conclusion is everybody who writes code should spend the next month doing professional development on how to write code using AI assisting tools. This is how code will be written from now on. And I'm certain that is true, right? I think one of the punchlines is if you're not using AI in writing code right now, you're probably missing out on a big opportunity. So what are the punchlines? First, I think it's clear that large language models are already really powerful coding assistants, but they have some important shortcomings, and I'm going to focus on those today. The models can have really important positive impact on coding efficiency and code quality, but they raise a bunch of important questions about how to educate people in coding, how to assess learning, and a number of important ethical questions. The work that I'm going to talk about today, I'll note, is in this preprint that's up on arXiv. So if you want to have a closer look, you can take a look at that preprint. I'm not going to say much about large language models. These are the models that underlie all of the current sort of state-of-the-art tools for AI-assisted coding. They're all based on a neural network architecture called a transformer. And in general, these models are simply trained to predict the next token, where a token is sort of an embedding of text. And so that's, in some ways they're very simple. Obviously, they're also very complicated. But what they really benefit from is sort of you taking advantage of huge amounts of training data. And so an example is the first kind of well-known AI-assisted coding tool was a tool from OpenAI called Codex, released actually a couple of years ago, and it was based on GPT-4, which GPT-4 was trained on a large amount of text. What they then took it and additionally trained it on a large amount of publicly available source code, including a bunch of Python code from over 50 million public GitHub repos. And some earlier analyses had suggested that that Codex performs better than most students on code writing questions in typical first-year programming exams. This model was deprecated earlier this year in favor of what's now called GPT-3.5, which is basically GPT-3 trained on both text and code. Now, some of you may also be familiar with GitHub Copilot. This is a tool that is sort of based on GPT-3.5 sorry, let me stop that for a moment. that basically helps you write code while basically, within your editor. So I'm going to show an example here of myself writing some code using it within the VS Code editor. So what you're going to see is I've written a comment here at the top, try to run each file in the code directory. And what it's doing now is just suggesting code, and I'm kind of tabbing through. So the white stuff that shows up is its suggestion, and I tab through and accept it. And you can see that it's basically kind of suggesting for me either lines, or in that case, like entire chunks of code if I didn't know better, I was thinking it was reading my mind, because it basically gave me code to do exactly what I wanted to do based only on that initial comment that I wrote. So, you can already see it's a quite powerful tool. A lot of the recent excitement comes around GPT-4, which was released in March, and GPT-4 showed itself to be, much more capable on a number of kind of standardized tests compared to GPT-3.5. So, for example, it now performs over 90% on the U.S. bar exam that you take to become a lawyer, and very highly on a number of other sort of standardized tests. And so a paper came out from a group of researchers at Microsoft who had done analyses on an early version of GPT-4, and sort of made a big splash based on the claim that they said, given the breadth and depth of GPT-4's capabilities, we believe that it could reasonably be viewed as an early yet incomplete version of an artificial general intelligence system. I think there's a lot of interesting questions around this. I'm going to focus on the coding abilities of GPT-4. So what they did in that Bubeck paper was they gave the system both Codex, GPT-3.5 and GPT-4 problems from this LeetCode platform where people go to practice and get tested on coding problems. And they, one important thing is to make sure that the problems weren't in the training data set. So they only use problems that were posted after the GPT-4 training period had ended in September 21, because the model in general is not getting, it's getting further refined based on human interaction, but they're not adding any training data to from more recent posts on the web. So what they saw was that GPT-4 performs on par with human LeetCode users across the range of problem difficulties, even so performs a little bit better numerically, at least on the hard problems. Now, many of you have heard about problems with large language models, and one of the main ones is that they can do this thing that people have come to call hallucination, which is basically making up details. So I put in who is Wayne Poldrack, and Wayne Poldrack is my father. He's a retired accountant living in Texas. He is not a prominent neuroscientist. He's not done any work in the field of cognitive neuroscience, and he's certainly not currently a professor of psychology or neuroscience at the University of Texas at Austin. I further asked it, what awards has Wayne Poldrack won? And it basically told me about a bunch of awards that he had won. Now, a few of these are honors that I've received, like fellow of APS and OHBM. But a lot of these are awards that I didn't receive, and I'm not even sure they all even exist. So it clearly shows that there's a problem for these models when it comes to sort of giving us reliable truth. But I think coding is in some ways sort of an optimal use case for these models, because they're really useful in cases where the work is difficult to generate but relatively easy to verify, right? And that's true of coding. So it's trivially easy to see if code is syntactically correct. There are tools that can do that, very quickly. And it's usually fairly straightforward to generate test cases to basically tell you whether your code is giving you the right answers. And so that's one of the reasons that I think a lot of people are excited about this, because it offers an opportunity to allow us to solve problems that we might not have been able to solve before, and to try to verify the answers. So I'm going to tell you about a set of experiments that I did. And first just starting out with trying GPT-4 on a bunch of coding problems that I had sort of made up by hand. The caveats are, one, the user, me, was fairly novice with prompt engineering, with creating the prompts to get GPT-4 to do what I want to do. We've learned a lot, even in the last month or two, about how to effectively prompt these systems, and I'll say more about that at the end. And I'll also say that in this first experiment, the assessment is completely subjective and qualitative, as you'll see, but I think it's still useful. So what I did was I took I had it generate a code for these 32 problems. I'm going to show you a few examples as we go forward. And I basically judged whether it was successful or not by as running with no errors and giving me an output that was reasonably close to what I was looking for by my subjective judgment. And I also, allowed myself to go in and give it additional prompts to try to get there. And I basically decided that it was not successful if I couldn't get it to solve my problem within a few minutes of effort, relatively easily. And so again, this is not a reproducible output. It's sort of really a qualitative judgment. Here's an example where it worked well. So I said, create a simulation in Python to do the following: generate synthetic data with 32 observations for 2 variables from a distribution with a correlation of 0.5, fit 3 models to the data: linear regression, second order polynomial regression, and ninth order polynomial regression. Compute the error for each of these models on the training and test data generated from the same distribution, and then plot the fitted lines for each of the fitted models overlaid on the training data. So if you know about machine learning, you know what I'm trying to get at here. And so we can kind of look at the code and see that it wrote, kind of pretty reasonable looking code. Like, it's relatively readable, clean, has a few comments telling us what it's doing. And this is the output. This is basically exactly what I was looking for. It shows me the training and test errors, and then it plots exactly the plot that I was looking for. Now, I want to talk about, what a really interesting thing that happens when you start asking it questions, which is that it seems to exhibit some degree of what, if a human did it, we would call understanding. At least, let me show you what I mean. So if I ask GPT-4, what concept is that simulation that I just showed you meant to exemplify? It says this simulation is meant to exemplify the concept of overfitting in the context of polynomial regression. This occurs when the model becomes too complex, performs well in the training data, but poorly on unseen data, right? I never mentioned the concept of overfitting in, when I was asking it for the code. And so it's clearly, pulling something out of its knowledge base that generalizes from the specific code to the concept of overfitting. Let's look at another example. I say, please generate a large number of samples from each of the several distributions: uniform, Poisson, beta, Cauchy, chi-squared, and compute the mean of each sample. Then present histograms of each of these sample mean distributions. And this is what it gives me, basically, on the first try, pretty much exactly what I was looking for. And then I go ask it, what statistical concept is this demonstration meant to illustrate, and how? And it gets exactly what I was looking at. It's meant to illustrate the central limit theorem. Basically shows that a distribution of sample means will approach a normal distribution as the sample size increases, regardless of the shape of the original distribution. But it also catches a little trick that I had put in there, right? It says it's important to note that the Cauchy distribution is an exception, as it doesn't have a finite variance. And so if a student in at least my introductory statistics class was able to answer that question this well, I would feel like they had a pretty good understanding of the central limit theorem. And so I think it's interesting that we can start to see what comes to look sort of like understanding coming out of these models. So now I want to show examples of sort of interactive debugging to see kind of what that looks like. So about a third of my attempts required additional prompting to solve the problem. And probably the most common problem was the use of outdated package features. So it would be because its training data ended in 2021, it would be basically trying to use old versions of packages that with, for example, functions or data sets that don't exist anymore. So occasionally it would actually hallucinate a non-existent package. It would say, hey, you should use this particular package, and I was not able to find that package anywhere online. Let's look at an example of how this worked. So I ask it to generate a Python class that fits a hurdle regression model, which is a model for zero inflated count data, where you basically the idea is like, first you model, is it zero or not? And then you model what's the count using a truncated regression model. And so it says, hey, that's what this is. Here's an implementation with a scikit-learn-like interface. And it gives me something that at least the interface looks good. But I saw that when I looked at what it had done, it's using linear regression, and that's not a model that's appropriate for count. So I said the continuous model should use a regression method that is appropriate for counts, and it doesn't really care about my misspellings. And it says you're right. It always says you're right. It never argues with you. So for count data, it's more appropriate to use a model designed for such data like Poisson regression. So it's going to use the Poisson regressor, which turns out to not be exactly right, as I'll come back to. So then I see basically it tries to run it, but it has an error because basically the data that it's using doesn't have any zeros in it. And for this model, the data needs to have some zeros. So I said that data set does not include any zeros. Please use an example data set that includes zeros. So it goes and pulls a data set, and it says here that it contains a count variable with zeros. It actually added zeros by kind of thresholding that number. So then it ran, and so I said, okay, now please create R code to compare these results to an existing implementation of hurdle regression. So it realized that, hey, I can find that within the PSCL package in R, and it gives me an R script to perform the same analysis on the same data as the Python script above. And when I look at the outputs, they are pretty far off from one another, right? For the mean squared error for the Python model was 7.75. The mean squared error for the R model was 108, right? So clearly something is wrong. And I had to do some manual debugging to figure out what was going on. And the main problem was that it had miscoded the prediction for the R code. It was basically coding things that should have been 1 as 0 and vice versa. I also turned off the regularization from the Python regression methods, and I actually got the answers to be pretty close, right? The Python model has a slightly higher mean squared error, but it turns out that when you dig into exactly how it did it, it actually is estimating the model in an invalid way. So the way that hurdle regression is meant to be estimated is you basically compute a likelihood for the hurdle for the binary part, you compute a likelihood for the count part on a truncated Poisson distribution because there's no zeros on the count part, and then you combine those likelihoods and you do maximum likelihood estimation. What it does is it basically separately fits a logistic regression model on the binarized data and then a count model on the non-zero data, but it used a regular Poisson distribution rather than a truncated Poisson, and so it didn't exactly get the answer right in a couple of ways. Now what's funny is if you go look on GitHub for hurdle regression models, everything I found did it in that incorrect way, exactly as I described. And so it's clearly kind of learning from the bad examples that are out on GitHub, how to, do the thing incorrectly. Now, about a little less than a third of the time, about a quarter of the time, I couldn't get it to give me a successful outcome. I tried several prompts usually and sort of gave up. Now, one time, one of those was a case where basically it needed a library. It needed me to install a library on my computer, and I couldn't get the library to work with my operating system. The rest were kind of more real failures, and I'll show you an example here. So the easy diffusion model is a model that people use in the reaction time literature to estimate a diffusion decision model, estimate the parameters for that model using closed form equations to estimate for example, this thing called quality of information or drift rate, which is called V, and a couple of other parameters. This was described in a paper by E.J. Wagmacher's a number of years ago. So I asked it to generate Python code to simulate a drift diffusion model and then simulate 1,000 trials from that model and estimate these 3 parameters using the easy diffusion model. And so it says, oh, yes, I know that model. Here's Python code to simulate the data and estimate the parameters. Now, when I go look at what it did, it actually misunderstood the model because the model is meant to be closed form. It should just have 3 equations for those 3 parameters. But what it instead did is try to basically build a loss and then do optimization on that loss to try to minimize the loss, kind of maximum likelihood or minimum loss estimation in this case. And so that's not the right way to do it, right? And so I said, well, the easy diffusion model uses closed form estimates for the parameters and doesn't require optimization. It says, apologies for the confusion. Once again, I'm correct. You're correct that the easy diffusion model provides closed form estimates. Here's some code to do that. And it gives us some code that looks like math, right? And it actually knows that V is the variable name that is used to describe this drift rate parameter. But when you look at the math, it has very little to do with the math of of the actual diffusion model, except for the fact that it's like exponentiating to 1/4 at the end. So it got like that little bit right, but the rest of this is, and it's like it's dividing by variance, but it's not using logits, it's not using the sign up here at all, and so it's completely wrong, and the answers that it gives are completely off. But it thinks it got the right answer. So to summarize my first explorations, GPT-4 is often really good at generating useful code, but it sometimes fails badly. And importantly, it never provides any signals regarding confidence in the answer, right? It always just says, here's some code, this will solve your problem. Which, from my sort of human eye, implies that it has confidence in what it's doing. And it unfortunately, we can't get access to the kind of underlying data that sort of could help quantify confidence. So my explorations kind of fit with this quote from the GPT-4 technical report, which is, care should be taken when using the outputs of GPT-4, particularly in contexts where reliability is important, which seems like that's science, right? So I think we need to be really careful. And I think, this is why, like, I don't really use GPT-4 outside of coding. There are a few cases where I think it's useful, like getting it to summarize what the internet thinks about a particular question. But anytime you care about the details being right, I would avoid using GPT-4 or any other LLMs for that matter. Okay, so now let's look at how good the code is. And this question was sort of inspired by, an interest that I've had in the last few years in sort of coding quality, which comes from, a lot of these ideas come from this movement called the clean code movement, Bob Martin being sort of one of the major sort of players in there. He wrote this book called Clean Code. So the idea is, clean code is simple and direct. It reads like well-written prose. It uses consistent coding standards. It minimizes complexity. And another idea from this movement is the idea of refactoring, which is basically taking existing code and making it cleaner or more maintainable without actually changing its behavior. You don't make it do anything else. You just basically make it better so that it'll be easier to maintain in the long and understand in the long run. So we wanted to see, sort of based on my initial intuition after looking at GPT-4 code, that it actually looked like pretty well-structured code and pretty clean. I basically asked it to refactor a bunch of code. So we went on to GitHub, grabbed more than 2,000 Python files via the API, which is incredibly slow because they don't want us to pull enough data to actually, build our own GPT-4. And we basically said, we're only going to take one file from any particular user on GitHub. And we did a bunch of other filtering to get rid of auto-generated code and other sorts of things. And we ended up with 272 files that we put into GPT-4 via the API. And this is work I did with Gasper Vegas and Thomas Liu at Berkeley. And we basically just said, please refactor the following Python code to be more readable, adding or rewriting comments as needed. And then we used a couple of tools to quantify the code quality. And I'll talk about the various ways that we did that. So 100% of our prompts worked in the sense of producing code. All of the original code had been free of syntax errors, according to our static analysis tool. And 97% of the new ones were free of errors. So it introduced errors in 3% of the code, syntax errors. Our first analysis looked at code formatting. So there are tools like static analysis tools, like the one that I like for Python is called Flake 8, often called linters, which basically look at code and they can identify syntax problems, but they can also identify formatting problems. And so this is a plot of the number of messages from the linter per lines of code. So each message is basically saying, hey, this particular thing is wrong with the code. The GPT-4 reduced the number of warnings from 0.24 per lines of code to 0.08, so by about a factor of 3 from the original code. So clearly it's generating code that's better than the original in terms of being more likely to follow kind of standard, coding standards and practices. These are examples of the various errors that were found by the linter, and you can see a lot of these are really kind of, picky errors like missing white space around operators, indentation is not a number of multiple of 4, kind of, common Python issues, a blank line with white space, block comment starting the wrong way. So a lot of these are kind of picky things, but they all add up to making the code more readable. And so it does seem that GPT-4 does a pretty good job of generating better code. It also seems to slightly reduce the complexity of the code. One thing you can do is just look at what are called logical lines of code, which is, like number of, if there's one statement that runs that's split across several lines, that's one logical line of code. So what you can see is that GPT-4 gives you code that's has slightly fewer lines. And then there's another measure called cyclomatic complexity which basically measures the number of different paths through the code. It also reduces that slightly. These are all both pretty small effects on the order of, I think, Cohen's d of 0.2 or so. So not huge effects, but both statistically significant. We can also look at another measure, and you have to take these measures with a grain of salt. This is a measure from the software engineering world called maintainability, which is meant to be a holistic measure of how easy it will be to maintain the code in the future, based on a number of different things like complexity that I mentioned, like this thing called Halstead volume, which has to do with the number of total and distinct operators and operands, number of lines of code, and percentage of comments. And you can see that, again, GPT-4 code seems to be, except for a few cases where it goes down, seems to be largely increasing in maintainability. Again, not a huge effect. Now, I mentioned earlier, so the takeaway from that is that the GPT-4 is pretty good at actually making code better, except in the few cases where it makes it worse and introduces errors. So now the question is, can GPT-4 successfully test its own code? We've seen that testing is going to be essential for any code that we use that's generated by GPT-4. So here we basically came up with a set of coding problems, and instead of coming up with them myself, I asked GPT-4 to generate them from 5 different domains of science. So for example, please generate 20 prompts to ask a chatbot to create Python code to solve a variety of physics problems. And then it does that. And then I embedded those into a prompt. This is one example. Create a Python function to model the population growth of a species using the logistic growth equation, given the initial population size, carrying capacity, and growth rate. So a problem from ecology. Please embed the code within an explicit code block. So that's so we can pull the code back out. Generate realistic values for any examples, and do not use any input commands. When we first did it, it was asking us to type things in, and we couldn't test things. Create code that's modular and well commented, then generate a set of PyTest tests that exercise each of the functions embedded in a separate code block. So we're basically asking it to generate code to do the thing, and then generate a set of tests that can make sure each of the functions is actually working properly. It successfully generated both code and tests for each prompt. And 97% of the resulting code executed successfully without error. So we're seeing a pretty small rate of syntax errors, but nonetheless they are they do exist. One thing we can look at then is what's called the code coverage, which is basically how many lines of the code in the initial program are covered by a test. And what we can see is that in general, it did pretty well. The goal would be 100% coverage. All the functions are being tested, and all the lines within each of the functions are being tested. And we can see that the more than 50%, about 60% of the tests had 100% line coverage. This is jitter, just so you can see everything. And at worst, it was down around 40%. But in general, it seemed to do pretty good at actually giving us tests that cover all the code. When we ran the tests, we saw that for just under half of the problems, all the tests passed. And at least one test failed for just more than half. And I'll show you an example of one of these failures, but when we look at them, in general, it was basically failure of an assertion, which means that the test had asserted that some particular thing should be true, and that thing wasn't true. When the code ran. The other is to failure to properly find an error or raise an error when that error existed. So here's an example. This is a code that was a function called escape velocity that was meant to compute the escape velocity based on the mass and radius of a planet. And this basically said, hey, these are the mass and radius of Jupiter. We'll run the function. And then I know that the answer should be 59564.97. So I'm going to assert that the value that comes out, this result, is close to that with a little bit of tolerance. We'll give it a 0.001 tolerance. But it turns out that the value that the function gave us was 60202.7, not 59564.97. The obtained value is different than expected. The problem here is we don't know which is wrong, right? We don't know if the code is wrong or the test is wrong. And we've not done detailed analyses to see, because it would take some domain knowledge to actually go in and figure out which of these is wrong. But it clearly shows that, the GPT-4 is really good at generating code to do tests, but the tests are going to ultimately need to be kind of manually validated by a human to make sure that they're actually correct. All right, so let's now think more about, rather than thinking of AI as a way to generate new code, think about AI as a coding partner. And that's the kind of the co-pilot model, right? AI is a coding assistant or a AI pair programmer, if you will. So let's ask, how can AI help us write better code? And one example is finding errors in our code, not just sort of syntax errors, but actually logical errors. So I created some code using GPT-4 that performs cross-validated classification, but it puts feature selection outside of the cross-validation loop, which is a problem. It's going to introduce bias because you'll have leakage data from test to train. And so I had to generate this code, and then in a separate chat session, so there's no shared context, I said, what's wrong with this code? I gave it the code, and initially said there's nothing inherently wrong with the code, and it tells me basically what the code did, and it gets it right? It's correct in telling me that. Then I poke it a little bit more. I say, there's a logical problem with how the analysis was performed. Can you identify it? Apologies for not identifying the issue earlier. After re-examining the code, I found a logical problem in the way the cross-validation loop is being performed. Feature selection is being done before the cross-validation loop. This might lead to data leakage. To resolve this issue, you should move the feature selection step inside cross-validation. Here's the corrected code, and it gives me code that actually fixes the problem. So this shows how, it can actually, you probably need to know that there might be problems in your code, but simply trying to put code in and see what it says could be a really useful way to try to find problems with code. A related issue is sort of code review, right? We think that code review, which means basically having other people look at your code, is really essential for improving code quality. But many labs, if you're the first Python programmer in the lab, you're not going to have other experts who can help look at your code. GPT-4 seems to be pretty good at actually reviewing code. And I think that this could be a big win for both the quality of code and also for education. So here's an example. I had written this for I'd written some sort of intentionally bad Python code for a clean coding tutorial that I had put together that you can find on GitHub. And it's basically just, it's terrible code, like terrible variable names, badly organized. It would be very difficult to sort of easily look at this. I mean, I'm doing factor analysis on something, right? But other than that, and you can kind of tell, I'm getting some health data and then some other data. So first I said, please provide a brief description of what the script is doing. And it actually does a good job. It says it's taking these health and psychological survey data, perform factor analysis, and examine the relationship between the resulting factors on the survey data and the health data. I then asked it, what are the Python anti-patterns that are present in the previous code? By an anti-pattern, I basically mean, so a design pattern is a good solution to a commonly encountered problem. An anti-pattern is a commonly used but bad solution to a common problem. And so there's a whole, if you go Google Python anti-patterns, there's a great website that has a bunch of Python anti-patterns. So I said, what Python anti-patterns are present? And it said, oh, there's a number of them. Here they are. Wildcard imports, single letter variable names, lack of white space, using magic numbers. It actually went on and found a number of other ones in addition. But these are some of the things that I had intentionally put into the code to make coders go find. So again, I think, just taking code that you have written and putting it into GPT-4 and saying, hey, what's wrong with this code could be a potentially really useful way to help improve your code. So in terms of like what my recommended workflow is right now for AI assisted coding, I think that if you're generating code de novo from scratch, GPT-4 is a good tool to try to do that for, especially for shorter pieces of code. I think for bigger, more complicated things, you might be able to get it to help with like making specific functions. And I'll say more at the end about, about techniques to maybe kind of help it do bigger things. But in general, it's going to be best for kind of short problems, maybe 100 lines of code or so, except for math, where it's going to make frequent errors, at least in some domains. I've heard from people who work in other domains that, sometimes it can get complex math pretty much right. It probably depends on the degree to which there are good examples on GitHub for the particular math that you're trying to do. Certainly novel math, it's not going to do a good job on. In my workflow, I don't use GPT-4 from the chat prompt that often. And that's because I'm usually working with existing code, or I'm working with kind of, like larger code bases where it's not easy to just say, hey, do this thing for me. So what I generally do is, have GitHub Copilot running. And one of the great things that, the Copilot can do is you just give it a prompt written as either a comment or like a doc string for a function, and it will generate that function for you. And in general, it seems to do a really good job. Now, right now, Copilot runs on GPT 3.5, still does pretty well, but it's usually like limited in how much it can give you. GPT-4 has a much bigger context window, and so that integration is going to bring improved performance. I'll also mention a set of cool new tools from GitHub Copilot called brushes. These are available in VS Code. I'm not sure if they're available in other editors, but the idea is that if you, for example, want to add type hints to your code, you can just grab this brush and just brush it over the piece of code you want to add types to, and it'll figure out what the types are and do that. Similarly, if you want to, make it more readable or make it more robust or try to clean it up, these brushes can help you try to do that. Now, I can't vouch for their ultimate accuracy. My guess is that they will usually work, but not always. But nonetheless, they provide really easy ways to apply very specific types of operations to code. So I think definitely worth playing around with. So finally, I want to talk about sort of some of the implications of these things. Clearly, the world is changing quickly due to the presence of these AI tools. And I'm particularly interested in scientific reproducibility. So first, I think there are ways in which they might improve science, right? I think they might make research code better, right? By giving people access to code review, by making it easier to actually generate tests. Obviously, you have to go in and fix the test or check the test to make sure that they have the right numbers and they're doing the right thing. But you don't have to learn all the intricate details of like writing a PyTest test. You don't have to learn kind of the syntax of PyTest tests because it'll just go write it for you. You can also make it really easy to not so much generate the data themselves, but to generate code that can generate simulated data if you then want to use those simulated data for testing your code. I'm pretty bullish on the way in which these tools are going to actually improve the training of researchers in coding. I think that in particular, debugging is probably the hardest thing about coding. And I think that AI assisted debugging can really help people improve their debugging skills, right? It's not going to solve the problem for you, but it can help you learn what to look for when you're debugging, or as sort of like a friend looking over your shoulder to help sort of find problems. Now, I think there are also ways it could harm science. You can imagine that if people are generating complex code without understanding what they're doing and particularly without care to checking the reliability of the code, we could end up with code that's just giving us totally invalid answers. And if we're letting AI generate the code and the tests, then that becomes a problem, right? Because nobody's watching the tester to make sure that the tester is actually getting the thing right. If it puts the wrong answers in on both sides, then you're going to potentially miss problems. It also definitely decreases the reproducibility of research outputs. And the challenge is that our interactions with any of these systems, at least any of the commercial systems, are irreproducible, right? You're never going to, because there's randomness in the generation, you're never going to get the same answer twice. And we don't have access to the random seed or the model version, which changes occasionally over time. And so I think this could be great from an educational standpoint, because you can see like what are the different ways to solve this problem. But from the standpoint of saying, hey, ChatGPT did this, if nobody else can get it to do that, we don't know if that's because the person did something wrong or just because of random outputs from ChatGPT. So I think that's, from the standpoint of reproducibility, it's really terrible. Now, as open source AI tools become more available, we might be able to start actually getting access to random seeds and be able to have a little bit more control. But I think they're still pretty far off in terms of their capability. There's a number of interesting legal issues, in particular around the work of OpenAI and Microsoft. So what they did, as I mentioned before, is they took a bunch of public code from GitHub, and most code on GitHub has no license associated with it, but some of the code is released under licenses like the GNU public license, which are referred to as viral or copyleft licenses, which basically say, they're kind of like a share alike license, where they basically say, if you're going to release this, if you're going to do something with this code and release the derivatives, those have to be released under the same license as the original. That's why they're called viral. Now, Microsoft and OpenAI claim that they say that there's no license on the outputs of ChatGPT, and that constitutes what under US law is called fair use. In the UK is called fair dealings. There's currently a lawsuit going on about this, and so it's going to be interesting to see how that works out. But there's also potential for liability, right? And this is, I think, a bigger issue for commercial people than for academics. Copilot these tools will very rarely insert code verbatim from the training code, right, from somebody else's code. And if you do that, are you liable for infringement? There's a new ecosystem now for companies of AI-assisted coding tools that will guarantee that they're not going to regurgitate training data, but we don't have access to those in academia. There's some interesting authorship issues that come up, right? So if you end up using AI for a large proportion of your work, are you required to disclose this? And does the AI deserve co-authorship? Interestingly, somebody thought it did. This is a paper that showed up on the medRxiv, I think last year, where they were looking at ChatGPT on the US medical boards, and they put ChatGPT as the third author on the paper. When it was published, they presumably were asked to remove ChatGPT from the author list. And publishers are now explicitly addressing this. This is Elsevier's policy regarding basically why they decided that AI and AI-assisted tools cannot be credited as authors. And they talk about, what do you do if you used AI? Well, they have a new declaration of AI and AI-assisted technologies in the writing process, where you basically are asked to say, did you use an AI tool or an AI assist in your writing? I personally, and there was some Twitter back and forth about this weekend, I personally do not use AI-assisted tools in writing, both because I don't trust their accuracy, and also because I think one of the most important things about writing is the way that it drives you to actually think about what you're doing. And if you're using AI to generate your writing, I think that you're missing out on probably the most important thing that writing does for us. Now, once you've written something, asking ChatGPT to improve it, in terms of style or grammar or things like that, I think is a reasonable thing to do, as long as it's not sort of, introducing any facts that weren't in the original. But in terms of like writing from scratch, I think that that's one of the most important things we learn as scientists. And I think it's a bad idea to use these tools to do that for you. There's interesting environmental questions. And you've all probably heard that the training of these large language models requires a significant amount of energy. So we don't actually know what it is for GPT-4. We weren't told. For GPT-3, it was about 500 equivalent of 500 tons of CO2, which is, roughly about, 200 American lives for a year worth of carbon output, or about 500 flights between New York and San Francisco. Now, training only has to happen, once or a few times, right? Inference, the thing that ChatGPT does every time you type in a question, that requires much less energy. It can run on a very small computer, but it happens more frequently, a lot more frequently. So we don't actually know what the carbon footprint is of that. It turns out that there's it's complicated, right? There's a lot of things that matter. You can change the model architecture, and in particular, you can change where the data center lives. If the data center lives, next to a coal burning power plant, then it's putting out a ton of carbon. If it lives next to a nuclear power plant, it's putting out almost no carbon. And so it really depends on sort of where, a lot of details about how things are being done. There are interesting access issues. So the work that we did with GPT-4, we had to pay for, right? The ChatGPT, in order to get GPT-4, you have to pay $20 a month. We had to pay money for the OpenAI API for our analyses. I think in total, those analyses probably cost a couple $100. So not super expensive, but not cheap. And this could exacerbate existing inequities between high and low resource institutions. There's also, most of you probably heard about the fairness and bias issues that come about from these models, and the AI coding systems inherit all those well-known biases. There's some discussion of this in the Codex paper from Mark Chen and colleagues, if you want to see more. There's a ton of interesting educational issues that people have been, in general, talking about for the last year around ChatGPT with respect to writing. With respect to coding, it becomes really hard to know how you assess students' understanding on, coding problems. You could try to take the route of saying, we're going to make you, work on our computer where you can't get access to AI and see how well you can do. But that seems kind of a losing battle, and it also seems to kind of lose out on the potential benefits of students actually using these tools. So I think we just need to think about how to teach coding differently, a much greater focus on debugging and testing and code review, and also thinking about how we can actually use LLM interactions when we're assessing knowledge. So having students actually work with the LLM to figure out coding problems, because that's in reality how they're going to be doing coding going forward. And I think, we just to kind of continue on that thread, I think we need to think about how can we train students to work more effectively with AI tools. People have started calling this programming 3.0, sort of programming as prompt engineering. And there's now a number of new ideas about the kinds of interactions that can improve the performance of these models. So one idea that has come out of initial work on kind of the reasoning abilities of large language models, some of the work from my colleague Noah Goodman here at Stanford, has come up with this idea of what's called chain of thought reasoning, or chain of thought prompting, which seems to do a much better job of helping these models actually figure out problems. So this blog post from Martin Fowler's blog talked about some work by this person, Zhu Hao, who had a large coding problem they wanted to solve, like a web server sort of thing. And instead of saying, hey, please write me a web server, they first started out giving the model a bunch of context, saying, here's the problems I want to solve. Don't write any code yet. First, tell me what the plan is going to be to write the code. And it gives back the plan. Then he writes instructions to say, okay, now generate this part of the code, now generate this part of the code, sort of more granular instructions based on that initial plan. And it seemed to actually do a much better job of generating code. And so I think we're currently just learning about what are the ways to interact with large language models that can improve their ability to generate good code. Finally, I think there's a ton of really interesting philosophical problems. So many of you may have heard of this sort of caricature of large language models as stochastic parrots, right? Basically just regurgitating what they've heard in the training data. And we certainly have to be skeptical about overblown claims of understanding. This recent blog post by Schur, I think, did a really nice job of showing how easily these models can break. They're showing a behavior that looks really smart, and then you just tweak things a little bit and they show behavior that looks really dumb. It's also pretty clear, though, that the newest large language models exhibit some emergent behavior that's hard to dismiss as simple regurgitation. I showed you some examples of that, and people are starting to do work to understand the mechanisms within these large language models for pattern abstraction. Like Chris Ola's group has been doing some interesting work on what they call induction his, which basically ways that the model can learn, well, oh, if I saw that A followed B over here, and then I see A again maybe B follows A, things like that. Kind of, higher order abstractions away from just a simple sequence. So I think it's a really interesting question as to when will we be ready to say that an LLM understands, and what does understanding mean in that context? So just to conclude, I think that you should all be working now with AI coding assistants, whatever you have available to you. I should note that if you're in an academic institution, you should be able to get a free access to GitHub Copilot via your educational email. And so that's a good way to get started. And you can also get access to GPT-3.5 via ChatGPT. These tools, I think, obviously they're really useful, but they also require really careful examination and verification to make sure that they're actually giving you the right answer. I think they're going to be incredibly useful for coding education, for helping people learn how to code, and sort of not having to worry so much about syntax and all the kind of like the relatively sort of surface aspects of coding, to think more about logical analysis, debugging, and testing. And then there's a ton of issues, ethical, legal, societal implication issues that are going to be decided in the coming years. And I think there's lots of interesting stuff to be done there. So finally, just want to thank my lab, who's helped me kind of think through a lot of these issues, and my collaborators, Gasper and Thomas at Berkeley. And I am happy to take some questions.
Thank you so much. That's really, really fascinating. I think especially the sort of issues around the legal and ethical sort of questions that arise is that's definitely something that I think we're going to have loads and loads of conversations about in the coming years. So enough of me talking. Let's open it up to other people's questions. So we have some different sort of questions coming in the chat. So I'm going to start with this one with the most upvotes. So do you think that your point around writing, that the process itself is important and makes you think about, makes you sort of learn to think about things in a specific way, can be applied to coding too? So what they mean is when you're learning to code, you're often learning to solve problems and to understand the principles of analysis that you're running. So is that something we can still retain when we use AI?
I think that's a great question and an interesting one. I mean, I think, one of the differences is that in general, when we're writing, we're taking a language that we already know, right, the structure of, and we're just we're basically generating, stuff from it, and putting that down on paper. Coding is, in general, when we're learning to code, we don't know the language, right? And we're so basically we're having to kind of like bootstrap ourselves into both knowing the language and then kind of generating examples from it. So I think that, I think the point is well taken. I'm less worried about, I'm less worried about the degree to which using coding assistance is going to reduce the thoughtfulness of what we do when we code, in part because you're still going to need to logically analyze the problem to get it to generate code that actually solves the problem for you. I'm hopeful that it will actually get people better at doing the harder parts of coding, but it's an open question. I think there's, people in the software engineering education world are going to need to do work to actually see, does it improve things or does it make it worse?
Absolutely. And I think this question now follows nicely from the previous one. So do you think ChatGPT should be used to help with coding only for people who are really experienced so that they can sort of spot the errors that might come up? Or is there a way it could be helpful for those who are just getting started?
I think it's useful for people who are just getting started because one, so the question is like, what would you do if you didn't have ChatGPT and you're getting started? You would go to Google and go to Stack Overflow and look for examples of how people do things. And sometimes they might work and sometimes they might not. And that's in part, that's what, ChatGPT has been trained on. So it's not that it's basically an easier way to find examples of things that will work to solve your problem. So I think it's, if anything, maybe more useful for junior coders. Like I have several software developers who work in my lab who are professionals. I don't think they're using these tools very much, in part because they don't feel like they need them. They feel like they're productive enough already. I know there is some research, not published, but at least on GitHub, suggesting that even, experienced coders can improve their productivity using Copilot. And that wouldn't surprise me because it can do, for example, it can write doc strings for you really easily, and it usually gets it right. So that just saves you time. But so I think that, one, just sort of seeing examples of how the problem could be solved, and then also using it, as I showed, as an assistant to basically say, hey, I have this code. Can you tell me what's wrong with it? I think those are going to be tools that'll be particularly useful for kind of junior coders.
Absolutely. And I think because we're still such early days now, it will, time will tell what direction we head with this.
Yeah.
So do you think in the future, when AI such as ChatGPT improves, it will actually reduce the number of jobs in programming or coding?
I think it's a super interesting question. It's hard to imagine that it won't reduce it somewhat. My guess is that, we're now seeing, so for example, there's a new tool that I don't have access to yet, but some people have access to on ChatGPT called Code Interpreter that basically will allow you, you can basically give it a data set, and it'll allow you to analyze that data set in basically natural language. Using basically, and it can show you the Python code that it generates to do the analyses that you're asking for. That suggests that there are going to be very basic level sort of, like data analyst sorts of positions that will almost certainly be impacted by that. Right now, I think that, most people who have jobs, writing code are working on much larger sort of things. And I think that these tools, at this point, the tools just don't, we have this thing called fMRI prep, which is a fMRI preprocessing toolkit, which is, tens of thousands of lines of code probably, right? There's no way that a tool like an AI assist tool could even get started at, kind of building something like that right now. It's just too big of a problem, too kind of sprawling, and it would kind of fall outside of it. Even the new GPT-4 with a larger context window of 32,000 tokens still isn't really going to be able to handle probably that. So I'm certainly worried that, about the implications of these things in the long run, and it's definitely going to change who gets the jobs, right? If you don't know how to use these tools, you're probably going to be much less competitive for programming jobs than people who do.
Yes, I guess it's a slow shift from Googling your questions to actually ChatGPTing your questions.
Yep.
We have another question about whether you think there is a difference in the outcome of the code based on the language that you use. So the person's saying that basically when ChatGPT is generating your answer, it will shift between different programming languages. And do you think it will matter what is the language that you actually want your output in?
Yes, certainly, because it has different amounts of training data for different languages. Now I haven't tested it much beyond Python. I've done a little bit of R stuff. But my understanding is that it's overtrained on Python more than anything else. And it's an interesting question. There's been some discussion on Twitter about is this going to cause Python to become the most prominent? It's going to continue to increase the popularity of Python. And it may well, kind of start to snowball on itself as because it does such a good job in Python, people may start using Python more. I've heard from people that it doesn't do a great job in Julia. I don't know much about other languages.
Okay, thank you. So I guess that shift towards Python has been happening for a while, and that is something that might actually accelerate that.
Yeah.
Okay, we're slowly coming to an end, so we have two more questions. So the first one is, what do you think about the Chrome extension Web Chat GPT, and do you think it's more precise in scientific studies or in general? Could it be more useful in coding than just ChatGPT?
I have no experience with it. Sorry, I can't answer that.
Okay, so we can very quickly move on to our last question for today, and I think that's a really nice to end on. So do you have any further tips on how to phrase the best prompt?
I think that, kind of giving as much kind of informational context as you can, because, what it's doing, the models aren't really, they're not like, changing their weights based on what happens during the chat. What they're doing is they're using, the more you write, the more information they have to constrain, because they have this, they're looking at basically a long sequence. And if you give it a bunch of information about what you're looking for, it's going to have more constraint on what it outputs. And so I think, the first thing is like whenever you give it a lot of information about the problem before you start asking for outputs. Like the prompts that I showed, the example prompts are like way too minimal and short. They were useful for what we were doing, but if you're actually trying to solve a problem, I think you want to start by explaining the problem and maybe use this chain of thought thing where you basically first say, how would you go about solving this problem? Don't write any code yet, and then start asking it for code. That would be probably the biggest, and from what I've seen, that's a pretty big improvement.
Okay, great, thank you. So thank you so much for being here with us today. This has been really, really great and really thought-provoking as well. And I think we all have loads to think about moving forward in our research. And yes, thank you so much. And thank to all of you for attending today.
Yeah, thanks for the opportunity. Bye-bye.
Bye, everyone.